Okay, so in this question, we're given three languages, L1, L2, and L3, and then we're asked whether L1 concat L2 union L3 is regular. So what you might think to do initially is you might think to actually compute L1 concat L2 and then take the union with L3 and then compute this new resulting language, try to inspect what this new language actually is, and then try to determine whether there could be an FA that accepts it, okay? But that path towards a solution would be quite tricky, okay? So in fact, the other thing that you could actually do is you could recognize that each of these languages, L1, L2, and L3, are regular, and we'll see in a second why. And then by recognizing that L1, L2, and L3 are regular, by the closure properties, we know that L1 concat L2 is regular, and L1 concat L2 union L3 is also regular. And so just a note here, in terms of precedence of the operations, we'll just assume that the concatenation takes higher precedence than the union. So first is the concatenation, and then it's the union, okay? And so it turns out that the answer to this is yes, and a proof to this is actually quite elegant. So an elegant proof can be used or can be created by using the closure properties. So using the closure properties, if L1 and L2 is regular, then L1 concat L2 is regular, right? And so let's just call this A. Call this new language A, right? So A is L1 concat L2, which is regular, right? Then if L3 is regular, then A union L3 is also regular. Why? Because A is regular and L3 is regular, right? If these two statements are true, then the union of two regular languages will also be regular, okay? And so all we need to do now, right? So then all we need to do now to show now is that each of these smaller or sub-languages, L1, L2, and L3, are regular. And so this is much easier, you'll see. So this is much easier than computing L1 concat L2 union L3 and trying to find an FA for this resulting language, right? So if you want to go through that whole path of trying to actually compute what the result of the language will be, and then trying to find an FA that exactly accepts all of the strings in that new computed language and only the strings in that new computed language, then go for it. But trust me, that path is going to be slightly more complicated than you think, okay? I might be speaking from experience. And so this other way of just showing that L1, L2, and L3 are regular, and then using the closure properties to then conclude that the whole language that results from the combination of these sub-languages is also regular, that's actually a much simpler path towards the proof of regularity, okay? So, right, so this is much easier than computing this operation and then trying to find an FA for this resulting language. Okay, and so then I essentially need to do three mini proofs. So I need to first prove that L1 is regular. And so to do that, I'll create an FA, right? So L1 is the set of strings that start with A. So Start with A. Then you need to read at least one B. So you need to read at least one B, and there could be many more Bs, and then you have to end with an A, right? And so then you go to a final state, right? So then that proves that L1 is regular. Then I need to prove that L2 is regular. So L2 is actually a set of strings. It's a finite set of strings. So all I can do in this case is just create transitions for each of those strings. So for B, and then for A, and then for B, B, A, and then I can create lambda transitions to each of these smaller machines, and then add final states to the end of the smaller machines that represent the reading of individual strings, okay? And then this proves that L2 is regular. And then lastly, I need to show that L3 is regular. Well, L3 is essentially any non-empty string that starts with an A, right? So it has to start with an A, okay? And then it can be anything, okay? And that proves that L3 is regular, right? So I know that these sub-languages L1, L2, L3 are regular, and now by this argument that I stated here, by the closure properties, I know that combining these languages in this manner will also lead to a regular language.